Welcome to Reducing Code in Hot Loops. A little bit of a long video, this one. You might want to grab a cup of tea and be ready for the disciplined art of refactoring. So in this video, we're going to explain that a hot loop is code that gets called often. So tick component is a great example of that. Any code in there gets called every single frame. So I want you to be aware of code that you know is going to get called a lot. And you want to make it very clear what happens every tick. So when you look at your tick component method, it wants to be super clear what's going on. So we're going to refactor our code for speed, but also make it ready for the physics handle code to be put in. By the end, the game will be doing exactly what it's doing now, but with a much better foundation. So no progress on the surface, but tons of progress behind the scenes. So let's roll up our sleeves and refactor this thing, making way for inserting the physics handle. The code just really isn't ready right now. So let's take a look through. Firstly, let's zoom right out to the header file. Remember what I said a little while ago in the previous section, that the public section of your header file really should sing what your class does. So we have a constructor, which is normal. We have a begin, play, and a tick, which are normal for any engine-driven class because the engine needs to be able to begin, play, and tick. The one thing that we could argue should be in the public would be grab and release. Now for this example, we're going to keep the grab and release here as a private, and we're going to handle the input as we have been inside this grabber class. But it's a little bit mixing concepts. Really, you could consider that we could have an input controller somewhere else, that this grabber registers with it, and that you actually, it's the job of the input controller, for example, or the player controller or something else to call the grabber and say, hey grabber, attempt grab, or hey grabber, release. And then we wouldn't have any of the input component code inside here. So just beware of that. But we're going to leave it here for now because it's manageable and it's simple and it keeps us just inside one class while we're trying to take on a lot of different concepts. All right, so the API is basically nothing. There's nothing you can do from the outside, which is fine apart from the caveat about the input I just told you. Fine, everything else looks good. Now what we want to do is go over to the CPP file and start thinking about, well, how can we improve things here? Right, so let's start at the top. The grabber, the constructor. Fine, I'm just going to get rid of a couple of empty comment lines there. Constructor is otherwise very simple. It needs to tick, so the tick has to be called, so let's leave it. Okay, now begin play. We want to run super begin play. We always leave that in place because the thing up the class hierarchy, i.e. the U actor component that we inherit from, may do some stuff in the engine that we want to be done. So you generally leave this in place. Grabber reporting for duty. We can probably lose that. Okay, what next? Well, I don't like begin play. It doesn't fit on one screen. So I'm just going to simply factor out the looking for attached physics handle bit. You can just literally cut the code. We're going to do this manually this time rather than letting the system do it for us. We're going to come down below and make a new method. So I'm going to indent it. And we've got to decide what method we would be calling here in begin play. What are we actually doing here? Well, we are find physics component. That's what we're doing. We're finding the physics component, only finding it, not doing anything else. So let's now void find physics component. Or physics handle component. Yeah, probably physics handle component. I'll do that in a second. So let's just rename this to physics handle component. See if the refactor tool will behave. Okay, void find physics handle component, and of course we need to pop this in the headed file. So it can just be down here, and this is find attached physics. Okay, cool. So we find the physics handle component. Better be good and just check that this still runs. There's no reason it shouldn't, but when you're refactoring, you want to be constantly checking that your code still runs. So trying to run this, we get an other compilation error. Now this is not a helpful error. Look here, other compilation error, doesn't tell you which file, and another error here talking about the make file. Interesting, nothing on the output. So here's a tip, here's a way of getting a better error. By the way, if you accidentally detach like this, drag the bar, drop it in there. Go over to Unreal and do your compilation over there. The reason is that the errors you're going to get in the output log in Unreal are going to be more helpful in general. So once it's compiled, let's see what error we get. See if we can track this down. Show the log. Okay, so it's saying that in grabber.h on line 42, it's not expecting a close curly brace. Did I miss a semicolon? Grabber.h line 42. Grabber.h, not CPP, interestingly. Ah, yes, I missed a semicolon on the end there. Cool, let's try again, see if it'll build. Now, not in here, back in Unreal, let's just click compile. That will, as I said before, actually save the file in Visual Studio, which is pretty helpful, right? So it's compiling away. I think it's going to fail again because I spotted another error when we were in there, but I want to kind of run home how to handle these errors because you'll create them when you're refactoring like this. So let's take another look at the log. Ooh, lots of errors. The question now comes, where's the first one? Okay, so we get to line 42 of Grabber CPP. That's the earliest line number, and it says physics handles not declared. Okay, so let's go to line 42 of the CPP. What's wrong with physics handle? So look through the comment and say, if I was a compiler and I'm reading this, why am I not expecting to read physics handle? Well, look, the problem is that in C++ you need to put the name of the class in front of the method name. So, boom. One way to prevent that happening, by the way, is to go to the H file in future, define your functions in here, right-click and say Quick Actions, Create Definition. But there you go. So that was the problem there. Let's go back and run. So hopefully this is useful stuff about how to track down errors. Start with the earliest line number, use the Unreal output. Good. So that's working. Okay, so let's carry on now at a little bit higher speed. We find the physics handle component. Now this next lump of code, what does this do? Well, I'm actually going to write the name of the method first, and I'm going to do it in the H file. I think this lot sets up the input component. So let's make one here. Let's make a method. Set up input component. Nice and simple. Void setup input component. Now, why am I bothering with a comment there, you might ask? As it is, it's not worth it. Set up attached input component or assumed attached input component. That's more useful because it reminds us that it needs to be attached. Now, if we were a little bit further into the course, I would be getting you to make these things attach. Well, this does attach itself, the input component, but I would be getting you to make the physics handle component attach itself rather than attaching it to the blueprint. But we're going to keep it simple. Okay, set up input component. Let's use the ability to create a definition over here. Now you have to wait a little bit, and there you go. You can jump to the CPP, and this time it's actually made us a setup input component. And it's put it immediately below find physics handle component in the same order as the header file. I like that. That's nice. Now that all we need to do is go find the code that I've highlighted up in the begin play, cut it, and pop it down into setup input component. Now, if you're a beginner, you're wondering, why is all this worth it? What's he doing? Well, bear with me a second. I'm going to put the comment above. You'll see that this will suddenly read a lot more nicely. Let's look now at our begin play. All we have to do in here is make the method call, set up input component. Okay, and look how clear it is what happens in begin play. You can also, if you put your comments above your methods, if you need extra commenting here, you can collapse down these two methods so we don't even need to see the lines with a little minus sign there, and then that's all super clear. On one screen now we can see exactly what goes on without worrying ourselves about the exact details unless we decide to go in and see what's happening. So I'll just sort out a little bit of indentation in here I spotted, and we're good to go. All right, let's continue to move down. What should we be doing when we grab? Well, is it actually a grab or is it an attempted grab? Let's leave it as grab for now, keep life a bit simple. What we're going to actually do is we're going to try and reach any actors with physics body collision channel set. We're going to reach out to that distance and try and do that. Then we're going to say, if we hit something, then attach a physics handle. Okay, we're going to do that later. So I'm going to put a to-do in. To-do, attach physics handle. I'm going to put a triple / here because we're probably going to have blocks of code. Okay, so that's the fundamentals of what happens on grab. Let's move down. What happens on release? Well, you say grab released, and then you to-do in a bit, release physics handle. We don't know how to do that yet, but we'll get there. Okay, now we're into a hot loop here. We're into an important bit, which is the tick component. The question is, lots of stuff happens in tick right now. What should happen in tick? Well, tick actually should be really simple. It should say something like, if the physics handle is attached, then we should just move the object that we're holding each frame. Otherwise, we just do nothing. Well, that makes it simpler, so all the stuff below needs to go somewhere else. So what does all this stuff below? We're getting the player viewpoint, we're reaching out to a certain distance, we're drawing a debug line, which I'm going to get rid of. I'm going to get rid of the debug line, we don't need it. We're setting up some query parameters, we're doing a line trace, we're seeing loads of stuff, which we don't need to be doing, any of it, unless we're actually holding on to something. Because it's when we push the grab that we're going to try and find something and do the line trace. So try and reach, let's say line trace, and see if we reach any actors with physics body, okay? So your line trace here, I'm going to put it in capitals, only when you push the grab key, only one quick instantaneous line trace, and we don't need to be doing anything every single tick. So what does all this code below do? Let's abstract it away into another method and not call it unless we need to, and then split it up further if we need to. Well, I think what it does is it gets the first physics body in reach. So I will put a little comment, return hit for first physics body in reach. And it's going to be something like this. What we're going to have is a method that is actually constant. It's going to return an fhit result, and it's going to be called get first physics body in reach. It doesn't need any parameters, but that does mean we'll need another helper function or two. Okay, and we're not actually giving it any implementation here. So that is the name of the method. Let's just go ahead and define it. Give it a second to pop the code in. There it is, pop over to grab a CPP. So let's try taking all of the code from the tick, all this stuff, apart from our comments about what it's going to do in the future, and put it in this new method. So first physics body in reach. There you go. We are going to have to return an fhit result, so paste all that in, and then I'm going to put this method at the bottom because it's kind of the latest code we've written. Just do that now, down the bottom here, below tick component. There you go. So let's go back up to grab and actually call the get first physics body in reach. That's what we're going to do when we grab. I'm just going to highlight those and go Shift Tab to go back. Later on, this is where we do the physics handle. Let's see what happens now when we actually try and grab. Does the get first physics body in reach work properly? And then we back roughly to where we were with the code all neatened out, apart from the problems all being kind of shuffled down to that huge get first physics body in reach method, which we'll refactor further in a second. Okay, so let's play the game. Grab, press and release. Let's get to the table. Aha, line trace hit, grab released. That's good. So the line trace is now hitting the things that we want. So that code is a lot more efficient now. The grab is working. We've got some more work to do attach the physics handle. And then there's a lot of stuff in get first physics body in reach. That might get further refactored when we start working with the physics handle. That's pretty good. Let's just have a look at our task list just to attach and release physics handle. All looking good. So at the end of this, you have absolutely no progress in one way, but in that your code does the same thing, but you've reduced a lot of work inside the tick component, which is taking a lot of stuff outside of the hot loop, and you have prepared yourself for where you're going to be inserting the physics handle code. So congratulations, that's refactoring. It's one of those things you just have to grit your teeth and do, and I'll see you in the next video.